Okay, so now we're just going to talk about counting ordered subsets. So before, we wanted to order the entire set, but in this case, we don't necessarily, or we don't need the entire set, although the other case is actually technically a special case of this where we're counting the entire set because the set is a subset of itself. But in a more meaningful sense, we are just counting a ordered subset. So if we have 4 objects, 4 people in a race, and we want to know how many possible breakdowns are there for first and second place. So let's say we have Alice, Bob, Charlie, and Dave. We've got a few different options. So Alice could come first, and then Bob could come second, Charlie could come second, or Dave could come second. Bob could come first, and then we've got the 3 other possibilities, A, B, D, D, A, B, C. Okay, so these are all of our possibilities. We've got AB, AC, AD, BA, BC, BD, CA, CB, CD, and GA, DB, DC. So how many? That's 12 possibilities. Or 4 times 3, right? Because we got the 4 first options and then can't choose the first option again, so we're stuck with the second option. Similarly, if we had 10 people and wanted to pick 3, then we would have 10 options for our first spot times 9 options for our second spot times 8 options for our third spot. So this guy is equal to, so this right here is equal to 10 factorial divided by 7 factorial. And it turns out that that's going to generalize. So if we have n people or n objects, and we want to know how many ordered subsets of size k are there, then it will be n factorial divided by n minus k factorial, right? Because what we're going to have is we're going to have n options for our first one times n minus 1 options times all the way up to n minus k plus 1. So this is going to be our last option. So that's equal to n factorial divided by n minus k factorial, because we have n times n minus 1 all the way up to n minus k plus 1 times n minus k times all the way to 2 times 1. This is n minus k times n minus k minus 1 times all the way to 2 times 1. So then we can just slash these guys out, and we're left with this right here. So this formula is equivalent to this formula. And that is how we count ordered subsets of size k for a set of size m.